Okay, boys and girls. Okay, we are going to continue last week lesson. Last week is lesson number 38. Okay, worksheet 38. Okay, before we continue with I think it's last page 6, 7, and 8. Okay, we do some revision first before we continue and discuss about that question. Okay, we learn about diffraction grating. So from there we can observe the bright dot. So at here there is a bright dot. Okay, so we observe it and then we can calculate numbers of the bright dot that we can observe. So always remember the formula that we use, d sine data equals to n wavelength. This one the n number of the order, okay, order of maxima actually is from the center here. This is n equals to 0, then going up n equals to 1, n equals to 2. Okay, so it is the same as the bottom part at here, n equals to 1, n equals to 2. So if this is the example, how many order of maxima we can observe, or how many bright dots we can observe? Answer will be 5. Why 5? This one is 2. This is the center bright dots. Okay, this one is another 2 dots. So plus the center at here. So total on the screen, we can observe 5 bright dots. Okay, so always remember the n actually is starting from the center, then going up. What is the order? Okay, n equals to 1, n equals to 2. Then the angle also starting from the center going up, going up. Okay, so when we apply the formula, we have to be very clear where we get the information. Okay, then after that day we got mentioning about this. When we calculate the d, okay, we want to calculate the d, we are using 1 over new number, okay, n. So here 400 lines per mm. Don't forget this is mm. We have to convert it into meter. So at here, the 1 times 10 power of negative 3 is changing from millimeter to meter. Okay, so this part have to be careful. Okay. Then y is 1 times 10 power of negative 3 over 400. Okay, here mathematic working step. Okay, so we come back to your page number 6. Yeah, that day we stop at here, page number 6. Okay, the light of a single frequency is incident normally on a diffraction grating and interference pattern of bright and dark fringes form on the semicircular screen. So if you are using semicircular screen, that means that our angle, maximum angle can be goes to 90 degree. Okay, we can observe until here. Okay, next, the wavelength. Okay, the light has the wavelength, so we label wavelength. This is nano, nano. So please remember convert it. So it will be 520 times 10 power of negative 9 meter. Okay. Then after that, the separation of the line. Okay, this one is already giving you D, so we don't need to do any calculation for D equals to 1 over N, no need, because this is D already, separation of the line. Okay, total number of the bright fringes. Okay, how many bright fringes, or we say, how many bright dots we can observe on the screen. Okay, so at here, we're using the formula D sine theta equals to N wavelength. So can you guys try? You got a D. Then how about your angles? Just now I told you, semicircular, that means that the maximum angle that we can use, we can go to 90 degree. Okay, can you do calculation and then tell me on the semicircular screen, how many bright dots you are able to observe? Okay, do your calculation right now. At the same time, I take attendance. Where is Tony? Yue Ting is not here. Tony not here. Boyang not here. Dinesh not here. Kai Qian, you only can score 2 marks. You only can score 2 marks. Maximum number of bright fringe or bright dots So in total along here. So Kai Chen, your answer is halfway. How about others? Vashini, correct. Yes. So what Kai Chen doing just now? What you get is here n equals to 0. What? So you count, but you only count for the upper part only. Wesley, less than 7.3. Come back to our worksheet here. You see this part. Since n is an integer number of maxima, the value must be, the obtained is a decimal, it must be round down. Okay, Wesley must round down. So if 2.7, then you only can goes to 2. Okay, so next, let me check others' answer. To be able to get the idea, let me have a look. Kai Chen, correct. Fawao, no. Fawao? Almost there. Okay, so dear, if you do calculation, you will get 3.8 times 10 power of negative 6 sine 90 degree equals to n. We don't know how many of the order maximum. So at here, 520 times 10 power of negative 9. I'm pretty sure you guys can get here 7.3, right? But as I told you, you have to round it down to 7. Okay, have to round it down to 7. But 7 is not your final answer. Why? Okay, because at here, we are always n equals to 0, n equals to 7. So that means that goes to somewhere here. The maximum at here, we can get 7. Okay, so in between here, we got 6, 5, 4, 3, 2, 1, something like this. Okay, so that means that in the upper part at here, total of the bright dots that you can observe is 7, right? You can observe 7 dots. Then bottom part at here actually is the same. It will getting 7 also until here, somewhere here. Okay, until here. So hard to draw. Okay, until somewhere here. It's okay lah. N equals to 7. Okay, but why I say our answer not yet correct is because don't forget n equals to 0 is also a bright dot, center bright dot. So at here plus 1 more for the center. So what is your total bright dots that you can observe along this semicircular screen? It's actually 15. So for this one that we observe is actually for the upper part only. For the upper part, not yet including the bottom part and also the center. So at here, your answer number, it should be 7 plus 7 plus 1 more. So actually, your answer should be 15. Okay, is that clear? This question actually same as, let me have a look. Same as this. Same as this. Okay, what is the total number of maxima observed on the screen? So at the end, can you see that I calculate n is equals to 8. So upper part is 8, bottom part is 8 plus the center, n equals to 0. So right now, this one also the same. Okay, so we calculate n equals to 7, upper part 7, bottom part 7 plus the center one. This is the total bright dots that we can observe along the semicircular screen. Okay, then if let's say they told you I got total 9 dots, 9 bright dots. So what is your n? Don't forget total 9 dots, including the center here is 0. So minus 1, so you got 8. Upper part is 4, bottom part is 4. So the maximum order on that we apply on the formula actually should be 4. Okay, should be 4. In order to apply the d sine theta equals to n wavelength, this n actually maximum is 4. This one. Okay, is that clear for this part? Is that clear for this part? Give me some response. Okay, Wesley, okay. Fatima, okay. Vashini, okay. Fawa, okay. Okay, deal. We're trying here for this. the light is replaced by a red light of a single frequency. Step where there the frequency of the red light is greater, less than, or same as the frequency of original light. Okay, original light is 520 M. Okay, so at here, original light, actually the wavelength is 520 nanometer. This one have to relate your knowledge about the EM wave. Okay, EM wave, did you still remember about the EM wave? Okay, Ramli, make Indian vegetable untuk ex-girlfriend. Ex-girlfriend frequency is high. Okay, then girlfriend is very slim, wavelength short. Okay, then visible light at here, we are starting from red until the violet. Okay, this is red. So at here, you still need to remember one more thing. Okay, for the violet is 400 nanometer. Then red color is 700 nanometer. Visible light, the wavelength you have to remember. Visible light wavelength you have to remember is 400 nanometer to 700 nanometer. Okay, you look at this. Right now, the original wavelength is 520 nanometer. How about the red color? Red color is 700 nanometer. So what happened to your frequency of your red light? Okay, so as I told you just now at here, can you see that girlfriend frequency is high? That means that somewhere here frequency is higher than your red color. Okay, so when your wavelength is short, frequency is high, is because V equals to F lambda. The speed for the EM wave is 3 times 10 power of 8. This is a constant value. Okay, therefore, V equals to F lambda, frequency high, wavelength will be short. Okay, it will be short. So at here, violet, near to the girlfriend here, gamma. Okay, so wavelength actually is shorter wavelength, but then the frequency actually is higher. Right now, we are changed to red color at here. What happened to your frequency? Your frequency should be less or lower frequency. Okay, behind here, I write down why. Because wavelength of red color actually is 700 nanometer. Then your original is actually 520 nanometer. So your frequency for your red color should be lower than your frequency of your original wavelength. Okay, so this frequency actually is greater than the original wavelength. Wavelength is greater. If you are using red color, then frequency will be smaller. Okay, a smaller frequency. Okay, is that clear for this part? Visible light ray, the wavelength you have to know is 400 nanometer to 700 nanometer. Any question? Okay, okay, state and explain the effect of this change on the number of bright fringes. Okay, the N. What happened to the N number when you are using the red color? Okay, D sine delta equals to N wavelength. You change the light, but you change the color of the light, but you didn't change the diffraction grating. What? This is constant. Okay, then this one is still using the semicircular. So at here, the maximum you still can getting 90 degree because everything set up is the same. Everything set up is the same. You're just changing the color of the light only. Okay, so now the problem is what happened to your N when you changing to your red color? So as I told you, your wavelength for red color, actually you are using a longer wavelength right now because you are using red color, longer wavelength. So when your wavelength here longer, what happened to your N? This part is constant, nothing changed. The whole setup is not changed. But now your wavelength become longer. In order to get back the same value, constant value, what happened to your N? Let me have a look, Taiqian. Yes, okay. So at here, the number of the bright fringe is less, become less. So at here, this one, wavelength increase, your N number of your N will decrease. Okay, so at here, number of bright fringe form on the screen is less. Okay, why? Reason. State and explain. So you need to give right because wavelength with red light has longer wavelength. So when we apply this formula, we found out that wavelength increase and decrease. This is the diffraction rating, the number, the slit, okay? So there is nothing to change. The separation of the line we didn't change, okay? And then we still using the whole setup at here, so which means that we still can get the maximum angle is 90 degree. So for this formula, the front part actually nothing changed. So when you change wavelength, then this one end will change, okay? So basically, this is the ideal. Why I attach this question is because I want to let you know that actually they assume that you know about the wavelength. Okay, you have to know about the wavelength for the what visible light. Okay, until here, any question? No question, then we are going to page 7. Is it okay? Fatima okay, Vashini okay, Wesley okay, Faval, Joray, Aichen okay. Okay, let's go. Okay, this one, a beam of light wavelength. Okay, this is wavelength. Okay, then after that, this is the angle. See, the angle always come from the center until major go up, okay? Then after that, okay, let's go here. The third order, so n equals to 3. Okay, at the angle, this is the angle. Find spacing D. Okay, can you do calculation? This one should not be a problem. Okay, do a quick calculation and then tell me the answer. Do your calculation and tell me your answer. Wesley correct. Okay, so d sine 68 degree equals to your third order wavelength. Wavelength is 4.3 times 10 power of negative 7. So your d 1.4 times 10 power of negative 6 meter. Let me check. Taichen, okay? Three significant figure, okay? Fatima, okay. So this one is just apply formula and then make sure you know where is the angle, where is the what is the end that you use. Vashini, correct. Okay, so dear, repeat again. Can you see that the angle is measured from center until you going up? Okay. Third order, how we get n equals to 0, n equals to 1 until n equals to 3. Going down is also n equals to 3. If they're asking you how many total bright dots we can observe, answer will be 3 plus 1 plus 3, so it's 7. Okay? Okay, the most important I put this question is because of this. Determine a different wavelength of visible light that will also produce a diffraction maximum at an angle 68. Okay, visible light wavelength. Again, what is the range? Answer is 400 nanometer to 700 nanometer. Okay, so just now for this question is 4.3. So just now this one, the wavelength, original wavelength is 4.3 times 10 power of negative 7 meter. So that means that 430 nanometer lah. Okay, so that means that the original wavelength is almost near to 400 here. So we want to propose another different wavelength of visible light. We must increase the wavelength. Okay, you cannot decrease your wavelength because that is not visible light anymore. Visible light is in this range. So at here, we need to propose a greater wavelength. Okay, d sine delta equals to n wavelength. Again, like what the previous question said that this one, when your wavelength increase, the n, actually we should using a smaller n. We should using a smaller n. So you look at this question, third order. Just now with the wavelength, they're using third order. Okay, so right now, if we want to using a longer wavelength, to find a longer wavelength, that means that we need to use a n which is less than 3. So we can trying with the number of 2, okay? So d sine theta equals to n wavelength. So at here, d is, just now at here we calculate the d. So for this one, this question we will use 1.4 times 10 power of negative 8. Okay, also at 68 equals to your n. And we should get less than 3. So we can use 2 lor. Calculate the wavelength. If you do it correctly, you should get 6.5 times 10 power of 7 meter, negative 7 meter. Okay, I got a question. Okay, for this one, you see 6.5 times 10 power of negative 7. Is it in the range of visible light? My answer is yes. It is equals to 650 nanometer. 650 nanometer. So the wavelength that we calculate actually is in the range of visible light. There is one question. Teacher, you said that wavelength increase and decrease. You choose n equals to 2. Can I choose n equals to 1? What do you think? Can I choose n equals to 1? And then do my calculation and find out my wavelength and use the wavelength as my final answer. What do you think? Can I use n equals to 1 to find my different wavelength? Wesley said no. Why no? Kai Chen said no. Jory said cannot. Yes, cannot. Okay, yes, deal. If you're using n equals to 1, you will be out of this range. It will no longer visible light. So for this one, it's almost at the end of the range at here. 650 nanometer is already end of the range. So if you want to choose n equals to 1 to find your answer, it's not possible. It will not be in the range of visible light. Okay? So is it okay? Okay, then any question? If no question, give me response, then we go to next page. Can you see that just now the two question and right now, just now the question and right now the question, applying the knowledge and then applying about the knowledge of the visible light. Okay, it's related. Okay, here the next one. Okay, this one actually nothing for you to memorize. Don't trying to memorize. We study smart, okay, dear? This one that I want to emphasize is it might have some questions like this. They're asking you what is the distance between the two ends of the screen. From here end until here, what is your distance? What is your distance from this end until here? Okay, how we do calculation? Okay, no need to memorize, but we're using mathematic way to solve it. They're giving you this. And then can you see that this is a triangle? Okay, this is 90-degree triangle. So actually, you can using a mathematic way. Okay, so you find out the angle by using our formula just now. You can easily find the angle. Okay, after that you got the angle. So you got this distance. Actually, you can calculate here. If this is your angle, this is your adjacent, this is your opposite. Okay, so we can using tangent. Okay, we can using tangent. We can using tangent delta equals to the opposite divided by adjacent. So after that, what you can calculate? You can calculate this part. You can calculate this distance, right? Then they're asking you what is the distance between two ends. Then you just times 2 to get the whole part. So don't need to memorize. Don't look at the formula at here, then you straightly memorize. Nothing for you to memorize. Don't memorize, dear. There is too many things to kill our brain cell. Don't. Okay, so at here, can you see that they provided the D? Okay, they're asking you to find H here, or maybe they're asking you to find the total H. Okay, it depends. So at here, you're using tangent. Okay, opposite divided by adjacent. So you get the answer. So for this, can you try? I already give you the hints. You can calculate the angle first. Then after that, you're using a mathematic way to find out what is your distance here. And then they're asking you distance between two ends. Then times 2 lah. Okay, do your calculation. Correct, correct. Good job. How about others? Only Jory get the answer? Let me check your answer. Vashini correct, Jory, Wesley correct, Jory correct. Fatima, Fatima check which part you make mistake. Okay, so Dio, did you get the idea? For this question, don't memorize formula. It's just using mathematic way to solve it. Okay. Fatima, able to identify what is your problem? What is your mistake? Manjo, able to follow Manjo? Prasan? Jahan? Kaichen? If okay, then we goes to lesson 39. Okay, we're going to the electricity chapter. Okay, chapter 9. Chapter 9 is short chapter lah. Okay, and then some more a lot of idea actually we learned it before. Okay, so electricity, electric current. Current is flow of charge carrier and measured in ampere. Okay, what charge can flow? There is only one charge can flow. That is called electron. Okay, so charge carrier can be a positive and negative or negative, but the one can flow is electron. So last times, actually, when the scientists they're trying to explain electric circuit, they're using the word of current. They think that current is flowing in the circuit, so the lamp is bright light up. Then at the end, when they go further and further, until at the end they found out that actually the one to make the whole circuit working actually is called electron. Okay, those they keep on mentioning current actually is a wrong idea. But because current is already used to explain so many application and so on, so they don't trying to get out of the current, the word of current. So they still maintain of using the word of current, but they slightly change the definition, say that current actually is the flow of electron which is in opposite direction. Actually no current such thing. But before they discovery about the electron, they thought the circuit word is because of the word of current. But at the end, they found out that no, it's electron making the circuit to work. Okay, but because the current, we already get used to using this word, so we still keep on using it. Okay, so what is the current? Current actually will be the opposite direction as your electron. Okay, so electron is the blue color here from negative here going out. This is electron. Current is from the positive going up. Okay, so we keep on using the word of current, but actually current is the flow of electron. Okay, current is the flow of electron. Okay, so here, quantizations of charge. The charge carried by the charge particle is quantized. So for this one, What is this meaning? It means that discrete or quanta. If you are graduate from SPM, then you will know this because quantum physics, we say that the light actually is in package, okay? Quantum is in package. So for this one, the charge carrier also in package, one package, one package, one package, okay? Then at here, the charge of electron is this. Okay, this one important. You have to memorize. A lot of questions they won't tell you. They assume you know about this. It's same like they assume you know about the visible light wavelength. Then they assume you know about the speed of the EM wave. So for this one, electron charge, they also assume that you know it's negative 1.6 times 10 power negative 19 C. So you have to know by yourself. Okay, this one make a star. Okay, here proton that is positive lah. Okay, so this is known as the elementary charge. Okay, the charge always occurs in multiples of the magnitude of the elementary charge. Okay, so at here Q equals to NE. Okay, Q equals to NE is the formula that we are using today. Okay, so for the Q is what I mentioned just now. Is the E in the formula is the one that I mentioned just now. You have to know by yourself. 1.6 times 10 power negative 19 C. Okay, Prasan asking question. They provide the electron input. Okay, yeah. Okay, then you have to refer back. Okay, but in the question they will not tell you unless you go back to the formula there and find out what is your E. For my suggestion, you memorize it. Okay, we keep on using this value. Okay, then Q equals to NE. This is the number of the electron. Okay, number of electron times the one electron is negative 1.6 times 10 power negative 19. Okay, but of course when we're using this formula, we don't need to put a negative for it. Okay, we just find total charge. Okay, we goes to your page number 2. Okay, which of the following value of the charge on a particle is possible? How I know it's possible or not? Again, quantizations. Just now we said that it's in package. If it's in package, the N at here, okay, Q equals to NE. The total charge at here, actually, total charge is at the front. Total charge at here. At the end, this value actually you should get an integer or we say whole number lah. Okay, so this one is Q equals to NE. 1.6 times 10 power negative 19. We find out the N. At the end, we found out that it's 6.25. Is it possible? This is the charge on the particle. Our answer is no. No. It should be a whole number. 5, yes. So this charge 8.0 times 10 power negative 19, this is possible. Okay, so we try with the past year question right now. Which charge can be carried by a charge carrier? Okay, which charge? A, B, C, D. Which one actually can provide you a whole number of N? Do your calculation. Prasan, correct? Jore, correct. So you have to count one by one. Kai Chen, no, Kai Chen, using this method, Q equals to NE, find out the N. Using Q equals to NE, find out the N for A, B, C, D. Okay, then you find out which one actually can give you a whole number. Vashini, correct. Fawal, correct. Kai Chen, try one more time. Wesley, correct. Okay, if you do it correctly, actually C will give you a whole number, which is you will get N equals to 3. Others should be getting some decimal. Okay, so here, next. Okay, so this one is asking you what is not a possible value for the charge? Not a possible charge. Because we understand the charge will be in package, whole number. 1 package, 2 package, 3 package. Okay, question number 2. Joreno. Joreno. Not a possible value. Not a possible value. Vashini, correct. Not a possible. Prasan, no. Prasan, no. Jore, yes, correct. How about others? So again, you have to calculate your n. Okay. So if q equals to ne, you calculate your n. Okay. The n at here, if not mistaken, at here, this one 0, this one 6.25. Sorry, 0.625, n equals to 3, n equals to 5. This is my answer lah. Okay, which one is not a possible charge? So at here, B is not a possible charge. It's because the charge actually must be in package 1, package 2, package 3, package. It must be a whole number. So B is wrong. Okay, is that clear? Can we go to the next page, page 3? Okay, let's go. Okay, electric charge. Current can also be defined as the charge passing through a circuit per unit time. Okay, so just now we say current is actually rate of change of charge, not change rate of charge transfer. Okay, here, so if we rearrange Q equals to IT, year 10 we already learned. Okay, then here what I want to emphasize actually just now that we learned Q equals to NE. Q equals to NE. So we can combine these two formula. Actually, we can get another new. Sometimes they will ask question and then using these two formula together lah. Okay. Again, the charge electron you have to know. Okay, next here. Past year question, only one question. Okay, here electric current. Label this is I. Don't forget this is milli. How many electron? This is number of electron in the 10 hours T. Okay, so how you solve? Which formula you are going to use? How many electron pass through? Okay, pass a fixed point in the wire in a time of 10 hours. Do your calculation. Jore, yes. Manjole, Manjo. Haichin, correct. Only two of you. Vashini. Q equals to IT. Then Q equals to NE. So at here, we can find the n by combining these two formula together. So NE equals to I times T. Vashini, correct? Okay, N times 1.6 times 10 power of negative 19. See, this is a partial question. In the question, they won't tell you. But you have to be very clear. Okay, this value you have to know. So I is 4 times 10 power of negative 3. Time is 10 hour. Don't forget that you have to convert, Wesley, correct? You have to convert it into SI unit. Why must be in SI unit, teacher? Okay, here, let me complete this one. 10 hours, then 60 times 60. Convert it into second. This one, convert it into second. This one, convert it into ampere. Okay, all the prefix you have to change. Prasan, correct? Manjo, correct. Okay, dear, why must be converted into SI unit? It's because this one is charge. Okay, and this one is, charge. So it is in column. Column actually is SI unit. Okay, then you see this one is the charge column. SI unit. So that means that the current that we use and the time that we use must be also in SI unit. Okay, must be tally lah. So at here, your n should be 9 times 10 power of 20, 9.0 lah. because they always want us in two to three significant figure. Answer will be C. Okay, is that clear, dear? Can we proceed? Okay, we goes to your page number 4. This is something new for us. Okay, just now what we mentioned, we learned in our SPM and also our IG lah. Okay, we goes to page 4. Do we always use 1.6 times 10? Yes, yes, correct. We just want to know the charge. Then the positive negative is just showing this is electron or proton only. Okay, so we just using 1.6 times 10 power negative 19. Okay, then here current in the current carrying conductor. In a conductor, current is due to the movement of the charge carrier, which is the electron. Repeat and repeat. Okay, so at here we will get a new formula in our A level. Okay, I equals to A and VQ. Okay, what is this and how we get this formula? Actually, you look at here. I equals to Q over T. This is what we already know. This formula is come from here. We derive. Okay, the charge. What is the charge that we want to calculate? Total charge. N times total charge. In this is a volume of electron. Okay, not only one. So that means that we are using the number of electron times the volume total. Okay, so N times volume, we will get N times area times the length. So this area times the length, this is your volume. Okay, the total electron times the E. Actually at here, this one is Q lah. Okay, we can write it as Q. Okay, Q. So at here, how we get the formula? L divided by T. Length divided by time. Okay, the length divided by time actually is your speed. Okay, at here we call it as drift speed. Okay, so from here we will get NA, then speed is VQ. So we get this formula. Basically, you no need to know how we derive, but I feel that nothing complicated, so can show to you how we get this new formula. Actually, it's come from here. Okay, so look at the formula at here. What is your I? Current. What is your A? Is cross-sectional area. What is your N? Okay, at here the N is slightly different with what we know just now. Q equals to NE. Here the N is called number of density of free electron. Unit is meter per meter cube. Density is what? Density is the number divided by volume. Mass divided by volume, right? Previously we learned. So at here is number of your electron per unit volume. This is the N that we want to say. Okay, N is the density of free electron. Okay, so we say number of charged electron, the electron per unit of volume. This is your N. This is your N in this formula. Then V is the drift speed. Then the Q is the charge. Okay, charge again. So if for the N, if you are a conductor, you will have a high value of N because you got more free electron. Okay, conductor is a good, we can let the electricity flow very well. Okay, the current easily to flow. So high current can flow. So at here, the high N value here is because more number of free electron. Okay, insulator, the N will be low. Then at here, the speed, drift speed is the average speed for the electron to travel through the conductor. So we are going to apply this formula. We are going to apply this formula on the page number 5, past year question. So until here, any question? We are going to using this formula. Any question? Okay, okay, the current at here, later on you will find out that some of the question they don't give you I directly. They give you V and R. So you have to know I is actually V over R lah. Okay? So we goes to the past year question at here. Nichrome wire has a resistance. So label this is R. Diameter, this is D. The number of density of free electron. This one is the N that we want in the formula. Potential difference is the V. Then what is your speed? Potential difference is the big V. Big V. This one is small v. Okay, so at here, let me have a look. They don't give you the I. They don't give you the I. Okay, we are going to using the formula I equals to ANVQ. Okay, the area, they didn't give us area also. Then how should you do? Don't forget area. This is the area, right? This is the area. Okay, area is pi d squared over 4. So you got the d, you do substitution in, and then using this formula, can you do calculation and then tell me your answer for your v? The speed. Do your calculation right now. Here we take note area pi d squared over 4. They didn't give you current, so you're using Ohm's law. V equals to IR to find the I. Area using mathematics pi d squared over 4. Then N is provided. Speed we don't know. Charge you have to know. 1.6 times 10 power negative 19. Machine correct. Good job. Machine, you try question number 2. How about others? Wesley correct. Kai Chen correct. Jorek correct. Okay, your answer should be B. If you do everything correct, 3.9 times 10 power of negative 6 ms negative 1. The V, current 0.4. So your current. Okay. Your V, dear. I'm so blurred. This is V. Okay. So boys and girls, we go to the next question. Is it okay for this question? You just need to identify what is your A, N, V, Q, what is your I. Where to find your I, where to find your area. Okay, is that clear? Can we proceed to the question number 2? Yes or no, dear? Okay, Vashini, okay, how about others? I move out, okay. Okay, dear, this question, we got 2 wire, X and Y, made from the same metal, highlight same metal. If same metal, same N. Okay, same metal will be same N. Okay, next, the diameter of the Y is twice of diameter of X. Wire X, Y, and battery connected in series. Highlight in series. In series, what physical quantity will be the same? What physical quantity will be the same? So let's say we got the battery, we got the 2 wire connected in series. Okay, so at here, what will be the same in the circuit? My answer is current. In series, same current, same I. Okay, so at here, calculate the drift speed for the electron in the wire X and wire Y. Okay, can you try? Those cannot, then you roughly have a look on my working step. Jory already get the answer. Oh, good job. Correct. Wesley, no. Fawal, no. Jory, correct. Washini. Okay, so I is equals to NAVQ. So for the x, actually Ix equals to Ax. Then Q is the same. V, we don't know, Vx. So at here, it will be Ix equals to A pi d square over 4. Then n Vxq. Then Iy will be nay Vyq. So Iy will be n. Then n right at here. Pi d squared. Okay, here. Pi d. But the d is double, 2d. Square over 4. And Vyq. Okay, so here it will become pi d square and Vyq. Okay, I always like to use ratio because ratio we can cancel out. Wesley, correct. We can cancel out some value. Okay. Washini, correct. Prasan, correct. Okay, I always like to using ratio. Okay, or here because we know that same current. So I can using Ix equals to Iy also can. So pi d square 4 and Vxq equals to pi d square and Vyq. Okay, because their n is the same. They are same material. Okay, same material, so same n. Then pi d cancel. Then Vx, Vyq also can cancel. Okay, so at here, your Vx over Vy, it will become 1 over, wait, 4 move up, 4 over 1. So answer should be donkey. Okay, the 4 at here move to another side. So it will become 4 over 1. So for this one, why I attach this question is because I want to tell you same matter, same n. And then this sentence bring a important knowledge about same I. If not, if you don't know about this knowledge, at the end you don't know how to find your I and X. You will thought that maybe they are different. Okay, but actually they are the same because they are connected in series. So current will be the same. Okay, any question? Any question? Fatima, okay, Fava, okay. Okay, dear, next question. I don't give you hints. Can you? Oh, okay, have to give you hints. Okay, this is the length. This is the length. This is total of free electron, but this is not n. This is not n. N is total electron, number of electron, divided by the volume. That is the n. Okay, then here this one is what is the when the potential difference is provided, then the free electron move with the speed. Okay, this is the V. What is the current? Okay, so I equals to NAVQ. We don't know the I. The n at here, dear, the n at here actually is what? It's not the 5.1 times 10 power of 22. We go back to our definition at here. The n in this formula is number of density, or we say number of free electron per unit of volume. This is n in this formula. So which means that the 5.1 divided by 10 power of 5.1 times 10 power of 22, this is not your n yet. You still need have the volume divided by volume. This is the n, okay? Then area, V, speed, 4 times 10 power of negative 6 times 1.6 times 10 power of negative 19. That is problem come out. Teacher, we don't have the area. We don't have the volume. How to do? I only have the length. So dear, here the testing on you. Do you know how to blend in your mathematics knowledge into physics? Okay, so volume is area times the length. So 5.1 times 10 power of 22 divided by area times the length. Then here times the area times the 4 times 10 power of negative 6. 1.6 times 10 power of negative 19. From here, actually, what they want, you cancel out so that you can use the length to solve this question. This is the challenging part for this question. Yes, Prasan, correct. So guys, you get what I mean for this question? You have to apply the knowledge of volume equals to area times length. Then inside the formula, we can cancel out. For the question, they didn't provide us. So we have to know, cancel, then using the length. Wesley, correct. Washini, correct. Okay, so if at the end, if you do it correctly, your answer should be C. Any question? Manjo, is it okay, Manjo? Jahan? Wesley, Tony is your friend, Run. Tony is your friend. Why he's absent today? Okay, here number 4. My dear, you do your calculation. Show that number of density in the wire is 8.5 times 10 power of 28. You don't know. Prasan, do you know? Where is Tony? Okay, ask him to get the video recording from me. Metal wire in the circuit has a length of 1.8. Okay, this is the length. Prove, dear. Try to prove. So this is aerial. Number of electron. Okay, so number density. Number density actually is the number of electron divided by volume. Where is the volume? Area and the length. So we times it up together lah. That's all. Per meter cube, because number is don't have unit. Number of electron don't have unit. Then per volume, this is meter cube per meter cube. So it's 1 over m cube. So it's per meter cube. Okay, so this one is just wants you to know how to calculate the density, number of density. Okay, for B, can you do calculation right now? Do your own calculation. Don't have I, what to do? So you have to think how to find I. V equals to IR or Q equals to IT. So at here, we got the Q, we got the time. Correct, Kai Chen, correct. Three marks at here. Please remember write formula, substitution, final answer. Okay? Wesley, no. Wesley, check. Which part you made mistake? Washini, correct. Okay, Wesley, you check. So how about others? Do you able to get the answer? This one, the N actually comes to here. I can be using V equals to IR to do calculation and find the I, but here this question doesn't mention. So you can use the Q equals to IT, whatever formula, as long as you're able to find I. Fawal, correct. Okay, any question? If no question, we go to your next page. Okay, let's go. Goes to your next page. Okay, here potential difference. This is just recall. Okay, recall back your knowledge. Potential difference actually is the work done in driving one column of charge across the component, or we say from one point to another point. Okay, work done, or we say energy lah. Okay, energy transfer for in driving one column of charge. So in year 10 and year 11, in year 11 and form 5, we already learned potential difference actually is across the component. Okay, the bulb is component and then the resistor is component. So at here, across the component, the work done in driving one column of charge, we call it as potential difference, or we call it as voltage. But for the battery here, power supply here, we cannot call it as potential difference. We call it as EMF, electromotive force. Okay, so definition for electromotive force actually is same, almost the same as the potential difference. Okay, just behind the sentence here is slightly different. Okay, why I didn't mention in this lesson is because after that we will have a next chapter we will learn about EMF. Okay, electromotive force. Okay, so at here, EMF definition is the work done in driving one column of charge. So actually from the first part is the same, energy per column of charge transfer. So work done in driving one column of charge to complete the circuit. That is EMF definition for EMF. So for the formula, in order to calculate the EMF, actually is same as work done per unit of charge. Okay, it's the same thing. Okay, so it's just the name is different. Here called EMF, here called potential difference, and then their definition slightly different at the behind part lah. Okay, this is to complete the whole circuit. So this part is from one point to another point, or we say across the component. Okay, so this is just recall. Year 11 we learn. Okay, a cell is described as having an electromotive force. Okay, EMF. So EMF is actually work done per unit of charge, or we say energy transfer per unit of charge. So A, B, C, D, which one is correct? Yes. Pasan, yes. Correct. Vashini, correct. It's the same thing actually, Prasan. You see, energy per column of charge transfer is actually work done in driving one column of charge. It's the same thing actually. Between 2 points across the component from one point to another point. So this sentence is correct. Okay, so this is just recall. So can we go to your page number 8? Yes or no, dear? No response? Yeah, something new on the page number 8 at here. Power. Seems like not new, teacher, but yeah, something new. Okay, the question will be more difficult. Wesley want me to repeat. You want me to repeat the definition, is it? Wesley, which part you want me to? Yeah. In year 11, we will always say that what is potential difference? The definition is work done in driving one column of charge across the component, or we say work done in driving one column of charge from one point to another point. But at here, actually, the meaning is the same. Energy transfer. Energy is work done. Energy transfer is work done. Work done is energy. So it's the same thing. Per column. Per column is per one column of charge. Okay, between 2 points, from one point to another point. So actually it's the same definition. It's the same thing. You can just using just now my sentence, or you want to using this sentence, whatever. It's fine. It's the same thing. Okay, if you are form 5, graded from form 5, also the same. You can using the definition. It's the same thing. Is it okay, Wesley? Okay, but if EMF, it will be work done in driving one column of charge, okay, across the circuit, okay, to complete the whole circuit. That is the difference. Okay, here, power is defined as rate of doing work. Okay, rate meanings in physics per unit time. So that means that work done per unit time, or we say energy per unit time. Energy per unit time. Okay. So potential difference is work done per unit of charge. That is just now what we know, work done per charge. Current is the rate of flow of charge. Okay, Q divided by T. Okay, rate means that per time divided by time. Okay, so at here we will get P equals to VI. So from P equals to VI, we can having another two more formula, which is the same. You will get the same answer for power. Just depends on the information they provided in the question only. How you get from P equals to VI, you get P equals to I squared R. Actually, you do substitution V equals to IR. Okay, you make V equals to IR, so that means that here is IR times I. So you get I squared R. That is the formula. Okay, how about the third formula for the power for here until here? Okay, this one is we do substitution for the I equals to V over R. Actually, still V equals to IR lah. So you see V, this one, V over R. So I will get V times V over R, V squared over R. So we get this formula. These three formula, you will get the same power, same idea of the power, okay? Same power, just depends on what information they provided to you. Then we choose, okay? If you forget another two, also never mind. We still can using this formula to solve. Whatever information that you don't have, then you're using V equals to IR to solve it. Let's say in the question doesn't give you the I, but they give you the V and R, then you're using V equals to IR to find the I, then you do substitution in. That's all. If a question didn't give you the V, but they give you I and R, then you do substitution for IR in. Okay, whatever. So if you forget another two, also never mind. You still can solve the problems. You just applying V equals to IR to find the unknown physical quantity. Then you continue applying this formula. Okay, then here number 5 is the things that I want to emphasize. In series, no matter in series or parallel, power is just added up together. No matter it's in series, in parallel, or it's a series parallel circuit. Just asking you total power, you add up all the power. That's all. Okay, so we look at this question. Which word equation must be correct? How is the power output? Okay, power R1 is equals to R2 plus R3. How we know? Actually, we don't know what. Unless we got the value, we do calculation. We don't know, right? Okay, R2 must be equals to R3. We also don't know. Maybe their resistance is different what? Because P equals to I square R. If the current is the same because they are in series, of course here current will be the same. But the resistance not necessarily is the same for R2 and R3. So we don't know. We don't know. Is it power 2 and power 3? Are they the same? We don't know. But see at here, power output of cell. Okay, so that means that total power in the circuit is actually the power dissipated at R1 plus R2 plus R3. Answer C is correct. So today in AS, we learn one thing. Power, no matter in series or parallel or series parallel circuit, just add it up together. Okay, just add it up together. Then A, B, D, we don't know is because unless we able to calculate it out, then we only can compare. It might having different resistance, so we cannot say that they will be the same. Okay, is that clear? Can I go to page number 9? Power okay. Ashini okay, Fatima okay. Okay, my dear, here. In the circuit, battery has EMF 6.0 V. Okay, we ignore the internal resistor. That is another topic in next chapter. We got 3 resistors having the same R. Total power is 24 watt. Can you do calculation to find out what is your R? Total power. Okay, do your calculation and then tell me what is your R. We have the V, we have the power, we have resistor. So we can using the formula P equals to V square over R. Well, no. Farewell, you only halfway. Farewell, you only halfway. What the answer you give me actually is total resistance, not R. Halfway only. Prasan, no. Prasan, you cannot divide it by 3. 2 is in series, then parallel with 1R. Farewell, no. You cannot divide it. Farewell, you cannot divide it by 3. Wesley, no. Jore, no. Jore, halfway. Manjo, halfway. Okay, total power 24 equals to the total voltage. You see, I draw the whole circuit. I combine total resistance. So in the circuit, total voltage is 6 square divided by RT. A lot of you stop at here, you get 1.5 ohm. But don't forget, if you give me answer C, you are only halfway. Halfway is because you are getting the total resistance, not the R, 1R. Fatima correct. Fatima correct. So dear at here, you have to apply the year 11 and form 5 knowledge. Here how we calculate the total resistance. Total resistance will be the parallel. Parallel, that means 1 over R plus 1 over, this is 2 in series. These 2 in series, so it will become 2R. 2R inverse it. Right, dear? So 1.5 equals to 1 over R plus 1 over 2R inverse it. 1.5 equals to times 2 times 2. So it will be 3 over 2R. Inverse it. So 1.5 will be equals to 2R over 3. So your R should be 2.3 ohm. Okay. Wow, no. Okay, check my working step and then identify what is the wrong concept, why you didn't get D, and which part actually you need to pay attention. Those you get C, you are only halfway. After that is the total resistance. Find out the R. You cannot straightly divide it by 3. Just now got few students giving me 0.5A. It's because you're using 1.5 straightly divided by 3. No. Do you able to get the idea about this calculation, the total resistance? We learned this before in IG and also in SPM. Parallel, then we have to using 1 over R plus 1 over the bottom part, total resistance is 2R. Then remember, inverse it. Okay, any question? So you guys able to know how to solve it and know your problems, your mistake? Manjo okay Manjo? Hai Chen okay already? How about others? Wesley? Fao Wao? Washini okay? Wesley okay? Fao Wao, did you able to identify the problems? Okay, next. Okay, in the circuit shown, the fixed resistor X is connected in series with battery and variable resistor. The power dissipated at X is 7.2. So power at X is 7.2. When a current, this is I, this is power at X. Okay, here what they want. The variable resistor is adjusted so that the power dissipated in the X increased by 50%. That means that the power X, new power X, now becomes 150% of the original 7.2. It increased 50%. Okay, so your new power right now actually is 7.2 times 150%. Okay, then after that, what is the new current? What is your I? Okay, so at here, how can you do calculation? Power and I. So let us check power and I. Okay, P equals to VI, P equals to I square R. These two formula, either one we can use. Okay, which one we can use? Is it having the same power at same voltage or they having the same resistance? Okay, we look at here in the circuit X. Okay, X is a fixed resistor. Fixed resistor. So highlight here, fixed resistor meaning that Rx remains the same. Okay, so meaning that we can using the power, new power is equals to the I square Rx, new I. Okay, here, how can we know the Rx, teacher? How can we know the Rx? Actually, just now this case, you can calculate the Rx already. From the first sentence at here, you can calculate what is your Rx. Because this Rx is the same all the time. This is a fixed resistor. So after we do calculation, we can do substitution in. Okay, we can do substitution in. So can you try? We're not using P equals to VI. It's because the V might be changed. The voltage might be changed. But fixed resistor, we understand the resistance value is not changed. Okay, it all the time will be the same. Prasan, no? Try again. So hints number one, calculate the Rx. Number two, find the new power, which is 7.2 times 150%. What is your new I? Rx is all the time the same, so you find the Rx first. Fawang correct. Jore no. Taichen correct. Prasan correct. You forget to square root it. Okay. Vashini correct. Okay. So dear, here px equals to I square r. Px starting is 7.2, then current is 3 square r. So your Rx at here, you should get 0.80 ohm. So we do substitution in. Because they are the same, fixed resistor, the resistance value will not be changed, okay? So at here, at the end, your I new. Don't forget to square root it, okay? So at the end, your answer should be 3.78. Oh, okay. If you are using I square R, you will get 13.5 ampere. That's why you choose D. But the answer is not D, it's because you have to square root it. So answer should be B. Okay, we got two formula related P and I. P equals to VI and P equals to I square R. Teacher, why you use this P equals to I square R is because look at here, the R at here all the time, it will be the same because this is a fixed resistor. Okay, fixed resistor. But if you're using P equals to VI, so you see, power is changing, new, this one is changing, but we don't know the voltage will it change or not. Okay, so we cannot sure. So after that, you do calculation for your V, then you do substitution in the next V. We cannot say that it will be the same. But fixed resistor, the resistance, yes, it is the same. Okay, so answer is B. Is that clear? Any question? No question, give me a response, then we go to page number 10. Fawa okay, Vashini okay. Kai Chen okay. Okay, then we go here. Okay, for this one. Okay, next question. Power output of the electrical supply is 2.4 kilowatt at a potential difference 240 volt. The two wire between the supply and the kettle. Okay, each have a resistance. Okay, there is two cable and this cable got resistance, so we cannot ignore it because it already told us the resistance. Okay, two cable wire and then kettle and then go back, so that means that this is a series circuit. Okay, this is a series circuit supply, that means that it giving. Okay, so here go back. So what is your power to the kettle? Power of the kettle. Okay, so dear, this is in series. So power total is equals to power of the wire, two wire, plus kettle. Okay, power, we just add it up together. Okay, so at here, they got giving us what? What information they give us? They got give us the resistance. Then what else we want? In series circuit, we can know the current is the same. In series, I is the same. Okay, so from here, this one, V and P. This is V, this is P. So from here, actually, I can calculate the current supply. Okay, so P equals to VI. Supply, supply, supply. Okay, calculate what is your current. Current can be applied in. Okay, apply into the formula here, current and resistance. So we can using I square R plus I square R. Don't forget this is two wire, so 2 times the I square R. So this is the wire resistance. This is the resistance of the kettle. Oh, okay, no need to calculate resistance because we want to find the kettle power. Okay, so total power is 2.4 times 10 power of 3. Can you do calculation? Find out what is your power of your kettle. Do your calculation to find out what is your power of your kettle. Washini, correct? Wesley, correct. Why times 2? Because I got two wire, dear. One wire Two wire. I got two wire here. Two wire. That's why I times 2. Total power is added up the whole circuit power. So here we got power for 2 wire and power for the kettle. Power correct. Okay, so at here, power of the kettle, it should be 2.3 times 10 power of 3 watt. So A and B, okay, potential different. If you get the power, you know the current because this is in series. In series, current will be the same, okay? Teacher, I don't know why my Wi-Fi very lag today. Maybe because of raining. I will watch the video. No problem, Manjo. Okay, here. Currently I will all upload the video to the YouTube, but only you guys having the link only can watch the video lah. I will share the link to you. Okay. So here power of the kettle V times I. I is the 10. Just now at here, if 2.4 times 10 power of 3 equals to your V 240 times IS. Your IS should be 10 ampere. Okay, so at here is V times 10. Power is 2300. So your V should be 230 volt. Answer should be A. Make it smaller. Is it okay, dear? Okay, so I repeat, here total power added up together. Y times 2, 2 wire. Wire power plus kettle power plus wire power. Okay, then this is total power provided to them. Then because this is connected in series, current all the time will be the same. So we can calculate the power from the supply here. With the current, with the resistance, so we can using P equals to I square R formula. P equals to I square R to do our calculation. Okay? Then any other question? No question. We go to the question number 5. Is it okay? Okay, let's go. A battery is connected to two resistors X and Y. The resistance X, Rx, is greater than Ry. State and explain which resistor dissipated more power. Okay, which one? What do you think? Power, we got three formula. P equals to VI, P equals to I square R, P equals to V square over R. Which formula you can use and do comparison? What do you think? In this series circuit, what will be the same? What will be the same? Yes, correct, Fawal. So can you tell me which one resistor it will dissipate more power? Wesley, correct. So what formula you are going to use to do comparison for the power, Wesley? Washini, correct. So, correct, Fawal. Okay, dear. You see, this is a series circuit. Series circuit. Okay, current is the same. So we want to compare and using the resistor. So at here, we can using this formula to do comparison. Okay, so current for X and current flowing through the Y are the same. So the only thing is we look at the R and P relationship. So when your R increase, your P also increase. Okay, so in this question, P increase when R increase, correct, Fawal? X, yes, correct, Vashini. So dear here. So which resistor? Resistor X. dissipates more power. Reason is because same current flow through X and Y, then resistance X greater than resistance Y. So using the formula P equals to I squared R. So higher resistance, then power dissipated will be more. 3 mark. Show the formula. It will be part of your answer. P equals to I squared R. So they understand that you are comparing because of this formula. P and R. Then same current is one of the point why we choose this formula is because in series circuit, the current will be the same. I want to compare R and P. Make sure others physical quantity is constant. Make sure others physical quantity is constant. Okay? No question. Then we go to your page 11. Is it okay? Okay, let's go. Okay, let's go here. This is 8.0 V connected to a resistance wire. The power dissipated is 36 watt. What is the current? I give P. Here, what else we have? V. So you know what formula you're going to use, right? Okay, do calculation right now and then tell me your answer. P, I, then we got V. Power correct. Height correct. Okay, your answer should be 4.5 ampere. This one quite straightforward. Power I, and then in the diagram provided you with the voltage. Okay, so at here is 4.5. Second question, the number of free electron, N. Okay, in time T, they give you time. Ask you to calculate relate. Okay, what formula can relate it? So do your calculation and tell me what is the number of free electron. Yes, Vashini, very good. Okay, NE equals to I times T. Q equals to IT, Q equals to NE. I just combine these two, okay? So N times the E, 1.6 times 10 power of negative 19. So 4.5 is what we calculate just now. Times the time is 50 seconds. So no need to do conversion because it's already in second. So your answer should be 1.41 times 10 power of 21. Number have no unit. Number of students are 22. No unit. Okay? Is that clear? Can you continue? Calculate the resistance R. So we got you got two methods to do calculation. You do it and then you tell me your final answer. Resistance. Correct, Vashini. What formula you use? Hai correct. Wesley correct. For this question, got two ways to do calculation. We got method 1. Okay, method 1 is you can using, let me have a look, Vashini using what method? Okay, power. Prasan correct. Okay, I can using V equals to IR. For method 2, I can using power to do calculation. P P equals to V squared over R. Okay, let me have a look. Fatima, yes, correct. Or you using others formula also can. Okay, here this one is X equals to the current 4.5 resistance. Resistance is 1.8 ohm or 1.78 ohm. Okay, I correct. So for this one is voltage is X divided X squared divided by resistance. I don't know. The power is 36. So your resistance should be 1.78 or 1.8 ohm. Okay, of course, let me have a look. Vashini just now using I square R. Using I square R also can. You'll get the same answer. But make sure your I at here is correct. If let's say I at here you calculate is wrong, you get 3.5, then the last question you will be wrong. Why I choose P equals to V square over R is because the V confirm correct is X. Okay, actually there is so many way to solve, but make sure if you're using the value that you calculate just now, make sure this value is correct lah. If you're using P equals to I square R, Vashini using this method, you will get the same answer. Okay, can I go to page 12? Power okay, Vashini okay, Fatima okay. Okay, let's go. The circuit in the figure is modified by connecting another second battery, same voltage, 8 volt, okay, parallel with it. By reference to the current in the resistance, so current what's going on, you have to explain. State and explain whether additionals of the second battery will cause the power in the original resistance to increase, decrease, or under stay the same. Okay, think. I add another battery which is in parallel. Will I increase the power, decrease the power, or stay the same the power? By reference to the current. So what's going on with the current and what happened to your power? What do you guys think? None of you got idea? Vashini correct. Good job. How about others? Ask yourself, when connected in parallel way, battery in parallel way, what happened with the total voltage provided to the resistance wire? Increase, decrease? And what happened to the current? Prasan correct. Fatima, no. Okay, deal. Let me have a look one more. Wesley, no. Prasan, correct. Okay, deal. Look at here. When they connected in parallel way, the voltage in overall voltage, or we say EMF lah, actually still remain 8.0 volt. Am I right? Then this resistance is a fixed resistance value. So your current, will it change? Current not change. But when we connected in this way, actually the battery can be used for longer time lah. Okay, so the total voltage or total EMF provided by the battery is still 8.0 volt, still the same 8.0 volt because they are in parallel way. Okay, then after that, the current flowing, since your power is the same, not power is the same, since your EMF is the same, then your current will be the same. Okay, so when your current is the same, does not change, then your power, of course, is still the same. Voltage not change, current not changed. At the end, your power is still not changing. Okay, so at here, write it down. Current in wire is the same. Okay, the EMF still 8.0 volt. This one at the end still EMF total actually still 8.0 volt. Okay, then here this one year 11 we learn Form 5 we also learning. Okay, then same potential different. Okay, how many volt received by this resistor? It's still receiving 8 volt, 8 volt, but 8.0 volt. It's still the same. Same potential difference across the wire. So power stays the same. Is that clear? Behind is the self-practice part. If you're facing any problem with the self-practice, because I write final answer only, you can message me. I will print screen for you the working step. Okay, if clear, then we go to lesson 40, resistance. Okay, resistance. So resistance is opposed the current. Okay, so your current is let's say your resistance is high, then your current will be low lah. You see, current trying to move. Okay, electron move lah actually. Current is because of the flow of electron. So the current flowing, why current can flow? Because the voltage pushing it. It must be something like supply to push it. Okay, it's the voltage, or we say EMF, okay, or potential difference. Push the current to move. But then resistance is the one that trying to limit the current to flow. Okay. Wire are often made from copper is because copper have a lower resistance. Okay. In the lab, we're using the crocodile, the connecting wire is actually inside is the copper wire. Okay, lower resistance. Resistance of the conductor can be calculated using the formula of the Ohm's law. So V equals to IR. This one we know already. Just recall. Ohm's law said that at a constant temperature. This definition is important because when you go through with the past year question, they like to asking you to define Ohm's law. Okay. Must be constant temperature. Okay. If temperature not constant, then your resistance will change. Okay, cannot. So current is proportional. Proportional means directly proportional lah. So at here, if you plot the graph, it will be the current against your potential difference. So here, directly proportional. Directly proportional will be like this. Okay. So this is the definition for Ohm's law. Just recall, nothing new. We already learned about this. Okay, we go to next page. Okay, resistance. Okay, resistance. So we just recall series, we add it up together. Parallel. Okay, parallel. Then we have to 1 over R1 plus 1 over R2 plus 1 over R3. I'm not encourage my student using this. It's because at the end, they always forget to upside down. Okay, so they will always forget one more step. So I will normally asking them to write it this way. Remind yourself, have to inverse it back. Okay, so change it upside down. Okay, so at here, this one, if there is some shortcut way for us to find the effective resistance, or we say combined resistance, if, only if, all the resistor at here connected in parallel, they having same resistance. We only can using shortcut path. If one of them is different, you cannot using shortcut path. Okay, how to do calculation for shortcut path? A shortcut way. So at here, 12 ohm and 12 ohm. You see, they are the same. Connected in parallel way. So we can using the resistance value, which is the 12, divided by n, number of the resistance having this 12 ohm, which is 2. So at the end, I get 6 ohm. Total resistance for this, 6 ohm. Settle. We don't need to do calculation like R total is equals to R1 over 12 plus 1 over 12 inverse it. So I got 2 over 12 inverse it. So I got 1 over 6 inverse it. So I got 6 ohm. No need. One way. Settle. Okay, this one, if I got 3, then 12 divided by 3. So I got 4 ohm. So from here, I want to emphasize, can you see that when we are connected in parallel way, your total resistance actually decreases. In parallel way, total resistance will decreases. This is the characteristic of the parallel circuit lah. Resistance, effective resistance in parallel always smaller. Okay, total resistance actually always decreases. So this one in series, total resistance always increases. Any question there? No question. We are going to page 2 and do partial question. 2 question. Okay, here, dear, come here. Can you find total resistance for this? So, technique is this one plus this one plus this one. Because they are in series one. This one R plus this one. Shortcut, because this is a shortcut way. Because what I want to say? Because they're having the same R. Okay, so this one is become R over 2 plus this one R over 3. Do your calculation. Prasan correct. Wesley correct. This one plus this one plus this one. Okay. The rest is mathematics. Vashini correct. Power correct. Okay, final answer you get C. The rest is mathematics. I'm going to solve for you. Okay, we go to the question number 2. Okay, total resistance in network 1 over network 2. Okay, do your calculation. Total resistance. Wesley correct. Any others? Only Wesley get the answer? Washini correct. The rest is mathematics, dear. This one cancel, so you get 2 R. So this one is 2.5 R. 2.5 is 5 over 2. So your answer will be 4 over 5. 4 over 5 R. R and R cancel. 4 over 5. Answer is A. Let me check. Fawal correct. Prasan correct. Okay, is that clear? Can we go to the page number 4? Kai Qian correct. Can we go to page 4? Okay, let's go. IV characteristic. Okay, the first one, straight line passing through origin. This is follow Ohm's law. So this is a ohmic conductor. These two is non-ohmic conductor. Year 11 we got learn ohmic conductor, it must be follow Ohm's law. Ohm's law said that, okay, this one I and V is directly proportional lah. Okay, so if here we found out that this is a constant gradient, then constant resistor. Okay, constant resistance. The resistance won't be changed. Okay, so they follow Ohm's law. So this one easy. Okay, so at here, next one, diode. In year 11, we learned about diode. Diode is a component that only allow current flow in one direction. It's help us to rectify AC to DC lah. Okay, so when the current is in the direction of arrowhead, okay, let's say at here, this is arrowhead. Okay, current is in this direction. Can you see that? Same direction, current. Then we allow current to flow. This diode will allow current to flow. So in this condition, in these situations, so we say diode is in forward bias. Okay, you will find out that, hey, we allow current to flow. We allow current to flow. Okay, then if you change your diode in opposite way, or you change your battery in the opposite way, you will find out that current flow in this direction come here, the diode will block it. The diode will block the current to flow. At these positions, we say that the diode is connected in reverse bias. If reverse bias, it block, it's because of what? High resistance. very high resistance. Okay, at reverse bias, the diode actually, the resistance for diode, okay, is very high. So when they allow current to flow, when forward bias, the resistance is low, they allow current to flow. Okay. So at here, the threshold, okay, each diode they have some threshold to trigger. Okay. So normally, but not all the case, normally it's like 0.6 volt. So starting from this point, they will start to allow current to flow. The threshold voltage, minimum voltage needed lah. Okay. Then at here, we can study a bit about the resistance. Okay, resistance. Just now, a straight wire, we say that resistance is constant. Okay, how about this? Okay, here, maybe I can write here. Okay, resistance is V over I. But in this graph, can you see that in this graph, actually what? The current over gradient is actually current over V. I cannot say gradient is resistant. Resistance actually is 1 over the gradient, upside down the gradient. Then only you get the resistance. Okay, so if I draw a triangle at here, and I draw a triangle at here, you will find that this one, the gradient actually is higher gradient. Am I right? When your gradient is higher, your resistance actually is lower. So for this diode, okay, for this diode, actually the resistance will be decreases. Okay, will be starting is high, then after that decreases. Until here, is that clear? Okay, so I draw the line. Instead of drawing triangle, I just draw a line to see the gradient, okay, the slope. Okay, so when the gradient is high at the end, it's steeper line. Can you see a steeper line? Gradient is high, actually resistance is decreases. Okay, filament length. Filament length. So this is filament. Okay, you will find out that the graph is like this. When current flowing through the resistance, okay, when current flowing through the filament, filament is the resistance wire lah. Normally we're using tungsten. Okay, from 5 students, we always asking in SPM, what is the material? Tungsten wire. Okay, the temperature will be increases. Why? Currents flowing through the resistant wire, we will producing heating effect. That's why when you're doing the experiment, we will always say, when you are not taking any reading, please open the switch. Okay, do not let the current keep on flowing through the circuit. If not, later on, temperature increases. Actually, you will change your resistance. Okay, so current flowing through the resistant wire, we will producing heating effect. So the temperature of the wire will be increased. Okay, so temperature increase, it will also changing your resistance. Your resistance will also increase. Okay, temperature increase, then your resistance will increase. Okay, is it increased? We look at this. See, draw the line and then draw the line. Can you see this gradient actually is smaller gradient compared to the starting here. Okay, it's less steep. Starting here actually steeper line. This is steeper line. This one is less steep. Gradient decrease. So just now at here, this one also the same. 1 over gradient is your resistance. Okay, so when your gradient decrease, your resistance will be increased. From time to time, current flowing through the filament lamp, the resistance will increase. Okay, is that clear? Is that clear? Vashini, okay? Any of you want to ask me any question? Fawa, okay? Haichen, okay? Okay, then we try past your question. Okay, the resistance in the filament lamp will increase as the current increase. What is the reason why resistance will increase? Just now I already got mentioned to you. It's because current flowing through the wire, it will having a heating effect. Okay, so Prasan, yes, correct. Answer is donkey. Heating effect will make a temperature increase. Vashini, correct. Jorek, correct. Okay, circle. Answer D. Okay, here, 10 seconds for you to identify question number 2. What is your answer? Which one is the metal wire? Which one is diode? Which one is filament lamp? Fawal, correct. How about others? Jorek, correct. Vashini, correct. Taichen, correct. Wesley, correct. Prasan, correct. Fatima, correct. Okay, answer B. Okay, then this one from starting somewhere here, threshold voltage. So this is diode. Okay, so this one the resistance will increase. Resistance will increase. So this is filament lamp. Answer is B. Okay, we do one more question. We do one more. So this one is a diode. See, this is a diode starting from somewhere here. Okay, we only can allow current to flow. So describe the resistance of the diode in the range 0 to 0.25. Okay, 0.025 from here to here. What happened to the resistance? Resistance for diode. What happened to the diode resistance? Any of you can tell me? Stay the same? Resistance stay the same? Resistance is very high or resistance is very low? Does it allow current to flow? Here, you see from here to here, I'm applying voltage, but no current can flow. Even I already applying some voltage to it, but no current to flow. What happened to the resistance? Yes, Wesley, correct. The resistance will be very high at this moment is even I supply some voltage, but no current at this moment. Here, the resistance actually is very high. Resistance is very high. Okay. Describe the resistance from V equals to 0.75 to 1.0. 0.75, maybe somewhere here to here. Okay. What happened to your resistance? Increase, decrease, or actually no resistance or very high resistance? Fawal, correct. Prasan, correct. So your resistance, you see, here and here. So actually this one actually is steeper line, steeper line. Steeper line, as I told you, gradient at here is 1 or I over V, but our resistance actually is V over I, so we need to upside down the gradient. Okay, so if I draw the line at here and somewhere here, we found out that the gradient actually is increase. Steeper line, resistance will decrease. So at here, we write down resistance decrease. As V increase, but resistance will increase. Is it okay? The rest of the question we continue next week. Next week should be able to finish our chapter 9. So I will give you chapter 10 in case we were entering chapter 10.